Dear students, today we are going to discuss the definite integral through antiderivative. That is how to find the antiderivative, this definite integral through antiderivative. We know that the definite integral of f of x from a to b, that is this integral a to b f dx, simply represents the area bounded by curve y equals to f of x and x equals to a and x equals to b. That is, if we have this function y equals to f of x, which is represented by this x equals to a and x equals to b. Now this shaded portion, that is the region, this shaded region, simply its area is given by this, or it represents this integral, definite integral. Now let x be any point in this interval a to b, that is x be the any point. Now if we consider y equals to f of x, so this means that if we denote ax by integral a to x f dx, then it represents this area, shaded area here. Now this function, because this is function of x, because here x is variable, this a of x is called as the area function of f. Now if f is continuous in ab, so this means that if we have a continuous function, then this derivative of this area function is always equals to this integrand, that is f of x. This theorem, which gives a dash of x equals to f of x, is called as the first fundamental theorem of calculus. Now if f is continuous in interval a to b and capital fxb its antiderivative, that is indefinite integral of a integral f dx, that is f of x is the indefinite integral of this small fx, then this definite integral from a to b f dx is always equals to f of b minus f of a. So this means that in terms of antiderivative, the definite integral is always equals to difference of their limit points in antiderivative, that is f of b minus f of a. Now this theorem, which gives us this, that is if capital fx is the antiderivative of this fx whose indefinite integral which we have to find is, and this equals to f of b minus f of a, this theorem is called as the second fundamental theorem. Actually this first fundamental theorem is it gives us the converse, it gives us the idea, or it gives us the condition under which the differentiation and the integration are inverses to each other. Since we know that if capital fx is antiderivative, then fx plus c is also antiderivative, then at that time the indefinite integral equals to like f of x plus c from a to b, now which is f of b plus c minus f of a plus c, which is simply f of b minus f of a. So in nutshell we can say that if f is antiderivative of small fx, then definite integral of this f of x from a to b is always equals to f of b minus f of a. So if you have to find simply the indefinite integral, definite integral, you first need to find this indefinite integral or antiderivative. Like if we have integral 0 to pi by 2 of cos dx, now here small fx is cos x, the antiderivative, that is integral of cos is sine, that is here sine lower limit is 0, upper limit is pi by 2, hence its value is upper limit minus lower limit, that is sine pi by 2 minus sine 0, which is simply 1. Now simply we can say that in order to find this definite integral, we firstly find the indefinite integral. We have number of rules to find, or number of methods to find the indefinite integral, like substitution method, like we have integration by parts, we have some standard rules. So firstly find the indefinite integral, then substitute the values of these upper and lower limits, we can find the definite integral. But we cannot apply the substitution method directly. Like if we consider integral 0 to 5 x square root x cube plus 1 dx, here f of x is x square root x cube plus 1. Now here we solve this integral by using the substitution, that is we have to put t equals to x cube plus 1, it have to put dt becomes 3x square dx, which implies that dt by 3 becomes x square dx. Now when x is 0, here limits of this integration are 0 and 5. This means that when x is 0, because we are replacing x in terms of t, so we have to replace the limits also. So when x is 0, substitute here in place of t x, we get t equals to 1. When x is 5, t is 126. So here the limits of this integration are 0 and 5, and the variable is x, but we change here the variable. That is why we have to change the limits also. So this means that integral 0 to 5 x square into root x cube plus 1 dx becomes 1 to 126, integral 1 to 126, because we have to replace t in terms of x as well as in terms of x in terms of t as well as limits. Now which is simply, now integral of root t is simply t raised to power 1 by 2 plus 1 upon 1 by 2 plus 1 by 3 is constant, it comes out. So after simplifying this, it is t raised to power 3 by 2, but limits are 0 to 1 by 0 to 126. Now substitute these values in terms of t. It is 126 raised to power 3 by 2 minus 1 raised to power 3 by 2. So this 2 raised to 2 by 9 into 126 raised to power 3 by 2 minus 1 is the indefinite integral of this. There is another way to solve this definite integral by using the substitution. Like here from 0 to 5 x square root x cube plus 1 dx becomes 2 by 9 t raised to power 3 by 2, limits are 0 to 1 by 6 1 to 6. But here if you replace t back in terms of x, then this becomes 2 by 9 x cube plus 1 whole raised to power 3 by 2, because t is here x cube plus 1. Now here variable is x, so we have to use these limits of variable x. Limits of variable x are 0 and 5, so this means that we have to here use 0 and 5 as the limits. So when we use 0 and 5 as the limits, because 2 by 9 into x cube plus 1 raised to power 3 by 2 is actually the antiderivative of x square root x cube plus 1. Use limits. Here you are using variable x, so you have to use the limits of integration as the limits of which are used in variable x. This means that substituting these values, we get 2 by 9 into 126 raised to power 3 by 2 minus 0 cube plus 1 raised to power 3 by 2, because x cube is here 5 cube, that is 125 plus 1, that is 126. This means that 2 by 9 into 126 raised to power 3 by 2 minus 1. In both cases we get the same result. So this means that indefinite integral in both cases is same. So you have to simply focus on the limits. If you are using the variable x at the end, then you have to use the limits of x. Now if you are using, or if you retain this x in terms of t, then you have to use the new limits which are obtained by replacing x in terms of limits, and you get the values of t. So in this way you can solve any indefinite integral by using the previous methods of indefinite integral which we already discussed. So in this way you can solve these all such integrals. Inshallah, in tomorrow's video lecture we will discuss the definite integral and its properties. So thank you.